Here is an idea almost everyone has from the movie Interstellar. Go near a black hole, and your clock ticks slower. 1 hour on a planet can cost 7 years back home. It feels like science fiction. But here is the surprising part. The big idea is real, measured, and textbook physics. What the movie does is take that real effect, push it to a dramatic extreme, and then add 2 or 3 things that leave the science behind. So let us do the honest version. What time dilation really is, what Interstellar got genuinely right, and where it dramatized, because being honest about the made-up parts makes the real science even more impressive. First, the idea everyone has. People picture time dilation as a clock that breaks, sit near enough gravity and your watch malfunctions and runs slow. That picture is wrong, and the truth is more beautiful. No clock is broken. Every clock ticks 1 second per second along its own path. The catch is that in Einstein's universe, space and time are stitched together into a single thing, space-time, and gravity is the bending of that fabric. 2 travelers can take 2 different paths through space-time, both perfectly healthy clocks, and simply rack up different amounts of time on the way. Time dilation is not a malfunction. It is geometry. Here is the part that flips your intuition. Think of driving between 2 towns. A straight road is the shortest distance. But in space-time, it works the other way around. The straightest, free-falling, do-nothing path racks up the most time. Take any detour, speed up, or sit deep in strong gravity, and you arrive having aged less. That is the real twins paradox. The twin who stays on the simple straight path through space-time is the one who ends up older. So when we say a clock near a black hole runs slow, we really mean it took a more curved path through space-time and harvested less time along it. And this is not a theory waiting for proof. We have measured it. We have measured this effect to almost absurd precision. The GPS satellites in your phone have to correct for it every single day, or your navigation would drift kilometers off within hours. In 1959, the Pound-Rebka experiment caught it across the height of a single building. And in 2022, a team at JILA in Colorado measured the difference in the flow of time across 1 millimetre, the thickness of a pencil tip. The clock at the bottom genuinely ran slower than the clock 1 millimetre higher. So the headline is clear. The clocks are not broken. The difference is a real, measured, geometric fact, not an illusion, and not a defect. Now to the movie itself. Interstellar is unusual because a Nobel Prize-winning physicist, Kip Thorne, actually did the mathematics behind its visuals. So the honest question is not is it right or wrong, it is which parts are real physics, and which parts are dramatic license. Let us score it, fairly, both ways. Start with what Interstellar got genuinely right. The black hole, Gargantua, is not an artist's guess, it is a real general relativity render, ray-traced from Thorne's equations, and it actually predicted features astrophysicists later discussed in papers. The time dilation on Miller's planet is a real consequence of sitting deep in that gravity. Falling across the horizon of a black hole this huge would feel locally unremarkable, no wall, no sudden crush. And because the tidal stretching of a black hole gets gentler the bigger it is, you really could survive close to a supermassive one, where a smaller black hole would shred you. For big swings, and the physics holds. Take the famous one, a Miller's planet, where 1 hour costs 7 years. Is that possible? Honestly, just barely. To get a time dilation factor that extreme, Gargantua has to be spinning almost impossibly fast, fine-tuned to within a hair of the absolute physical limit, roughly 1 part in 100 trillion. Thorne worked out that this is technically allowed by the equations. So it is not fantasy, it is real physics dialed to the ragged edge of what is permitted. The 7 years number is honest in principle, and wildly fine-tuned in practice. We will flag it as right, but dramatized. Now, fairly, where the movie leaves the science behind. The spin needed for that 7-year planet is so fine-tuned it is best called marginally possible, not realistic. The traversable wormhole at Saturn would need exotic, negative energy matter to hold itself open, something never observed, and possibly impossible. And the ending, the tesseract, sending love and data back through time inside a black hole, leaves physics entirely. That is storytelling, not science. None of this is a criticism. A film is allowed to dramatize. The point is simply to know which line you are standing on. The wormhole deserves a fair word, because Thorne took even this seriously. It is not drawn as a flat hole in space, it is rendered as a sphere, a crystal ball showing the lensed, distorted galaxy on the far side, which is what a real wormhole would actually look like. The geometry is honest. The catch is the ingredient. To keep a wormhole open long enough to cross, you need a kind of matter with negative energy that no one has ever found. So the shape is good physics. The thing that would build it is, for now, pure speculation. So why does the honest version matter? Because the lazy take is to either swallow the movie whole, or to sneer that it is all nonsense. Both miss the truth. Interstellar is the best source science fiction ever made, precisely because a working physicist ran the numbers, and it still chose, knowingly, to dramatize a few things for the story. Holding both of those at once is the whole skill. The real universe genuinely does bend time near a black hole. The clocks really do disagree. And we have measured it down to a millimetre. That is not less amazing than the movie. It is more. So here is the honest takeaway. Time dilation is real and measured, not a broken clock, but the geometry of space-time, where the straightest path harvests the most time. Interstellar got the headline right because Kip Thorne did the calculations, the black hole render, the dilation, the survivable giant horizon all hold up. It dramatized the rest, the impossibly fine-tuned spin, the exotic matter wormhole, and the love through a black hole ending. Knowing exactly where that line sits does not spoil the film. It is the thing that makes the real science land. Time dilation is real, geometric, and measured down to a single millimetre. Interstellar got the big physics right because a Nobel physicist did the maths, and it dramatized the spin, the wormhole, and the ending, which is completely fine for a story. The sources are on screen. If a no-hype, genuinely honest look at the science behind the screen is useful to you, follow AI Edge Lab. We keep the wonder honest.